The identification of subscriber in 5G is playing an important role as it is used to identify both subscribers and the network functions where those identifiers are stored. So, for example, the GUTI is identifying the AMF ID plus the TMZ for the subscriber. So let's try to explore what are the identifiers used for the subscribers in 5G. So the first identifier for the subscriber is the SUPI or SUPI, which stands for Subscription Permanent Identifier. And this identifier is used at the subscriber level. And the SUPI is the main permanent subscriber ID in 5G network. It's globally unique 5G subscription permanent identifier. The SUPI is used only inside the 3GPP systems. And it is provisioned in the UDM UDR, which are used for storing the data or the subscription data for the 5G network. And it will be based on either the MZ or the network specific identifier. And the SUPI is protected over the network using another identifier, which is the SUCI, which we will describe next. The second identifier we use for the subscriber in the 5G new radio network is the SUCI. And the SUCI is standing for Subscription Concealed Identifier. And actually it is a privacy protection identifier which is used to contain the concealed SOPI, as we mentioned before, because the SOPI is built using the MZ or the network ID identifier. The SUCI is a one-time use subscription identifier, and different SUCI are generated after the SUCI is being used. Then we have the BEI, which is the Permanent Equipment Identifier, and this one is used at the user equipment level, and it can take several forms depending on the user equipment use cases and depending on the user equipment type. At this time, the user equipment will indicate the BEI, the Permanent Equipment Identifier, and the format of it to the network. And if the user equipment is supporting at least one 3GPP technology, it must be allocated a BEI in the EMI format. So if you remember the EMI is used to identify the user equipment in the previous generations. So it is like a number which is given for the handset. And here the BEI is like an identifier, a permanent identifier for the user equipment. And we mentioned before that the user equipment is either mobile handset, a sensor, or another object. The next identifier is GUAMI, which stands for Globally Unique AMF ID. The GUAMI is used to uniquely identify the AMF within the 5G network. And if you remember, the AMF is the access and management function. So the GUAMI is comprised of some fields. Those fields are the MCC, the mobile country code, the MNC, the mobile network code, the AMF region ID, the AMF set ID, and the AMF pointer. The next identifier is the GUTI or the GUTI, which stands for Globally Unique Temporary Identifier, and it is used at the subscriber level. So the AMF, which is in charge of the subscriber, is responsible to assign the GUTI to the user equipment. And the GUTI is a common number or identifier which is used with the 3GPP or non-3GPP access. The GUTI can be reassigned to the user equipment at any time, and the 5G GUTI is equal to the GUAMI number plus the 5G TMZ. The last identifier we have is the 5G TMZ, which is a temporary identifier assigned by the AMF, and it will be unique within the GUAMI. And the 5G TIMSI, as we mentioned, is used plus the GUAMI to constitute the GOTI number, or the 5G GOTI identifier. Here, we will try to explain what are the identifiers used on the network level of the 5G new radio. So we have the first one, the AMF name, which is used to identify the AMF. And the AMF name is a globally unique number. And you should note that the AMF can be configured with one or more GUAMIs. The second network identifier is the NCGI, the new radio cell global identifier. And this one is used to identify the new radio cells globally. The NCGI is constructed from the B element identity, the cell belonging to, and the new radio cell identity. The third network identifier we have is the GMB ID, which is the G node B identifier. And the G node B identifier is used to identify the G node Bs within the BLMN. And the G node B ID is contained within the NCI, the new radio cell ID of the cell. The next network identifier is the tracking area identity, the TAI. And the TAI is used to identify the tracking areas. And the TAI is constructed from the BLMN identity, which is a tracking area belongs to, and the tag, which is a tracking area code. Then we have two network identities which are linked together. The first one is single network slice selection assistance information, and the second one is network slice selection assistance information. So the first one, which is a single, is used to identify the network slice and is used by the user equipment in the access network in the PLMN, in which the network slice selection assistance information is associated with. And the second one is the network slice selection assistance information without the S, without the single. And this identifier is a collection of the single NSSAI, and up to 8 is allowed, and requested NSSI can be used or can be sent in the signaling message between the user equipment and the network. The last network identifier we have is the DNN, which stands for data network name. And the data network name is equivalent to the APN because both identifiers have an equivalent meaning and they are carrying the same information. The DNN may be used for many cases or for many functions. So for example, the DNN can be used to select the SMF and UBF for a BDU session. It can be used to select the N6 interface for a BDU session. And it can determine the policies to apply to this BDU session. So like this, we have finished the identifiers for the user equipment, for the subscriber, and for the network. And here, a list of the references that you can try to visit in case you need to get more information and more details about the different topics that we are discussing throughout the course.